Hi everyone. Good afternoon. Like say good day. I don't know if you can hear me. Welcome to this live coding section. If you can hear me, so you can see that you can hear me.
Yes, you can. Go on.
Okay. Welcome to this live coding section brought to you by Harmony. My name is Professor Bell. I'm a senior legal scientist at Harmony. So I'll start sharing my screen now so that we can start. So can you see my screen now?
Yes, you can.
Okay. So today we'll be talking about web scraping. Web scraping. I'm sure all of you will be like, what is web scraping? And I'm sure a lot of people have gone online to search for web scraping and to know what it's all about. Now, I would like to kind of explain what web scraping it is, what it means, and how many Python libraries you're going to use, and what are the libraries and what do they do, and all. So, web scraping is an automated gathering of data from the internet. In the past, it's commonly known as screen scraping, data mining, web harvesting. Web scraping is the process of extracting structured and unstructured data from the web. So one of the libraries you're going to use is request. You're going to use request. Then you're going to use LSML. You will also use Beautiful Soup. And there are also advanced Python libraries like Selenium and Scrypty. You understand? So for today's section, we're going to be using requests. We're going to use the HTML parser. We also use you're going to use Beautiful Soup, which is the most commonly used Python library for web scraping. It creates a parser tree for parsing HTML and XML documents. It creates a parser tree, a parsing tree, This is a format at which the information you are deriving from the website, it creates a format at which the information you're getting from the website, how it should be, how it should appear. That is what Beautiful Soup does. It brings it out in a format where it should be, appeared in your script, in your Jupyter notebook. So that is what the Beautiful Soup library does. So Beautiful Soup does this scraping automatically. It converts incoming documents to Unicode and outgoing documents to UTF-8. So that is for Beautiful Soup. And just like I mentioned, it's a commonly used Python library for web scraping. So let's talk about request. Request is one of the important Python libraries of Python used to make a request to your website of your interest to retrieve a particular data on its page. Excuse me. Getting the HTML content of a web page is the first and the foremost step of web scraping. So how do you now get these things from the website? Like, let me open this website now. Let me get this website we're looking at today. So I will just put it on my browser. So So this is the website now. I believe you all can see it. Now, the question is, how am I going to get information I'm looking for in this website? How am I going to get the information? You know, this website is filled with information, basically for film for children and all. Toy Story 3. That's the title of this website. This is it. And you're asking yourself a question, how am I going to get information I'm looking for? Like at this point now, in this section, we'll be deriving information from this site, from this particular view. I want to know who directed this, who directs most of their film, who screenplays the film, who is the storyteller, who produced the film, how many characters do they have in the film? You know, just like starring Tom Hanks, Tim Allen, Joan Cusack, Wale Shawn, these are the people, the actors in the film. Then this is the cinematographer. Will I say the person who took the record of the film? Or the director of photography? Most times that's what a cinematographer is called. Then this is the person who edited the film. This is the music. This is the person who produced the music used in the film. Production companies, this is just distributed by release dates, the running time. So we want to get the information about the film, who directed it and all. So how do we get that information? What Python library can we use to extract information from this website? That is what web scraping is all about. So moving back to our script, we have found that request is one of the Python library used to extract information. So request is one of the important Python library tools of Python used to make a request to your website of interest to retrieve a particular data on each page. So we use request library now to retrieve this information here from this particular web page. So it's just like getting the HTML content of a web page. You understand? We're trying to get the HTML content of a web page. So that is what we do. And to get it, we need to use requests. So now we are requesting that website to give us a particular information. So that is what it means. Now we know we also have another Python library, LSML. So this LSML library, what it does is that where the request library cannot pass the HTML content without the LSML or HTML parser. So what this LSML does now, it creates a passing Python library that helps the HTML and the SML information you get. It creates a passing. I don't know how I'm going to explain it. So what the LSML does is that it creates a passing condition, do you understand, where the HTML content cannot, we also have we also have LSML where request library cannot pass the HTML content. So where the request library cannot pass the HTML content, that is what LSML does. It creates a passing condition where the HTML content can, pass through. So that's mostly the work of the LSML. And LSML is quite fast, more than HTML parser, but they do the same thing. They create a passing format at which the request library can, pass the information. So all of these people, they do their different jobs. LSML does its own, request does its own, Beautiful Soup does its own job too. So what Beautiful Soup library does is the most used library, as I have explained. It creates a parser tree. It creates a parser tree. While LSML creates a passing content for the request library to be able to pass the information it's getting from the web page. I don't know if I've really explained this. So moving forward now, we start. So what I did here, I tried to install the Beautiful Soup before, I PP stored it to ensure that my beautiful soup is being installed in the computer node. So this, like I told you, we're going to create this new data set creation. We will go through the link and scrape what we need and create data set with it. You start importing the necessary libraries. So here, I imported the request. I imported url.request, import url-open. So from beautiful soup, I imported beautiful soup. From beautiful soup 4, I imported beautiful soup as BS, imported request. This is the request library I was talking about. Then I imported pandas as PD. Because the work of these pandas is to help whatever you have gotten from the internet, it puts it on a structured form. It puts on a data frame, format where you can have lines, delimiters, separating each column. So I'm going to run this and see it work. So this is it. So we have this particular format. This is how this pd.set underscore option read.read 30,000. I'm just saying, okay, whatever I have gotten from the internet, this is how I want the width, the math columns, and the column width. This is how I want it to be. I want it to be in this format. So it doesn't appear haphazardly and it doesn't appear scattered or appear very small. So I have already arranged how my width will be, how the columns are going to be and all. So this is what this particular thing is about. So right now I'm going to load the page, the web page. The web page is this is the Toy Story 3. This is the website. So I'm going to this is the website. So I'm going to I named it as a variable HTML. So for now, I'm not using URL-OPN. I'm using request.get. So request and URL-OPN, they do the same job. But in this section, I'm using request to extract the data from the website. So that is running, you have to wait for it. So I can even say, okay, let me call what I extracted. So this response shows that it has worked. This is the programming language that shows that what I was trying to extract was successful. So move further. So at this point, I'm going to use beautiful soup to know the content of this R of the HTML document. So I named the beautiful soup as BS object equals to BS bracket open arrow dot content. Okay, so I'm trying to know the content. Beautiful soup, like I told you, it creates it in a parser tree format. So when you run this, then you come and like this prettify function helps to put it in a string format where you can easily understand and read it. So when you do this, okay, you have whatever you got from the internet here. So this is it. These are all the informations in that website. These are all of them, the skeletal format, or the tree format, or like call it the parser tree format that they mainly look like. So this is it. So moving forward, we're going to, so if you want to get a specific object in the page you visit, right click to scroll down to inspect using the function find to extract the information you need. So what this is trying to say is that now what we are looking for is this information here. That's what we're looking for. So we can kind of highlight this place here, and right click to inspect this particular page. So the more you put your cursor around, it will direct you to look at here now. Look at this page you're looking for. It's been highlighted. And the class, the attributes that will help you extract the information from this particular place is info boss velvet. This is the attribute we're going to use to extract this information. This particular information here that is highlighted. I don't know if you understand me. So if you drop this thing down, you see the T-body table and all. So what we are looking for, we're not looking for information here. We're looking for the information here. So you just scroll down. You're looking for all the information, as I told you. So when you go around here, you notice that place has been highlighted. It means what we need to get this information is here, is this particular attribute, which is class equals to infobus velvet. You understand? So I'll go to the Python Jupyter notebook to use that same class I saw there to get the exact information I'm looking for. Use the same attribute, which is class equals to infobus velvet. You get? So, and in Beautiful Soup, there's a function called find. This find will help you, get whatever information you're looking for in the website. Do you understand me? So when you run this, it will produce all the information. See, look at all of them. It has been run already. So look at all the information. All the information in that place. So I had to now put it in a beautified format, and it also printed out all other information. See, all the information I'm looking for. Yeah, okay. Well, you cannot be able to understand these because they are not in a format where in which you can be able to have a understanding of what it's all about. So moving forward, I would like to. I have gotten what I'm looking for, but it is not clear yet. I need to, bring it in a format where it can come out like this, where it can come out in a dictionary form, like directed by, screenplayed by, that kind of a thing. So you have to make it appear the way it's showing on the website. So what I'm going to do, I will now say, okay, to extract the table rows of the information you have started to extract. So at this point now, this particular one up here has lots of table rows. So I need to extract the table rows. So what I do, that's okay, information box dot find all TR. Information rows equals to information underscore box dot find all TR. So when you run this, okay, we're having error here. Information box is not defined. So what happened before was that I did not run the previous cell before this one. So running this right now, if I call on my information rules, so you can see all the rules of that website. So moving forward, I will just say for row information rules, print row.creatify. So I'm looking for row in information rules. So that's how you get the information you're looking for. Exactly. Yeah. You can see this title refers to the of which. So you can also see another one. Title Michael and date. See another title, John Lasseter, Andrew Staton. So these are the people, these are the information we are looking for. So for row in information, so this is what, so I have to move forward to further explain how we're going to extract that particular data. So at this point, this cell is trying to explain, assuming I want to extract few rows to build a dictionary of key value of the rows in a table, a dictionary format. Using for loop to iterate and extract the rows. But since I don't want all, I will use enumerate key. Because when we said we want all the rows in that particular class, it brought a lot of rows, but that's not what we're looking for. We're looking for a particular row. So how you're going to use the for loop to iterate and extract the row we are looking for. But since I don't want all, I will use enumerate key row to get exactly what I'm looking for. So defining a function to find all the list items in that rows. So at this point, I define the function which is def get underscore content underscore value bracket open loop. And that's okay. If row dot find that I want in that row, I want to find all the lists, which is represented as Li. So if it's so, please return string of the list, the string of that list, which is Li dot get the test of the list. That is the test here. You know, this is test. So want the test of this particular information. That's what it's trying to say. For Li, for all the lists in row dot find all Li, that's the list. So else return row dot find td dot get underscore test. So is either so what this function is trying to say is either you're getting the list or you get the table. So this thing here, right here, is also a table. So either way, you just get the table. So when you run this now, so at this point now, you know this function, we just have to build the function. Later we're going to call it when we are building a dictionary. So at this point, this is a movie information. We're trying to create, because that table we're trying to extract is an information about Toy Story, Toy Story 3 movies. Sorry, it's an information about Toy Story 3 movies. Okay, these are the Toy Story 3 movies, and these are the informations who directed the movie and who screenplayed it, just as I mentioned earlier. So they're getting the movie information. So for index, comma, row in enumerate information rows. If index is equals to 0, I want to get the title and I want to row dot find the table head dot get test. So what I'm saying here is that if this is index 0, I want to get the title. And obviously this is index 0, right? This is directed by index 0. If you guys are familiar with indexing in Python, you should know that this is index 0, this is index sorry. The title we're talking about is this particular toy 3. This is the title. So this is index 0, then this is index 1. But we are not looking for pictures, we are looking for information. Then this is the next one is index 2 and moving downwards. So I'm saying if the index is equals to 0, I want moving information, which is title, equals to row dot find th. That's the heading. Th is the table heading. Dot get test. Elif. index equals to 0, equals to 1. If the index is equals to 1, continue, do not find anything. Okay, so that's why we did not put movie underscore information title dot equals to blah 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 and all. Do you understand? Because we don't want to get pictures. So we're saying, okay, pass it and continue. So else, moving further, content key for the remaining ones, that's for the remaining index, want content key to be equals to row.find th.getText. Then this content key means we want it to be in a key and a value form. Like the key now is the director, the directed by, while the value form is the name of the director. So we now say content underscore value equals to get underscore content underscore value row. That's where we are calling this function we defined here right now. We're saying we want all the information here to come to play. Okay, I don't know if you're understanding me. So we'll now say, okay, this movie underscore information, we are bringing the content key here equals to the content value, which means we want the information to be in a key, to be in a value form, where the key we call the value. So when we run this now, you see that it brought out the exact information we're looking for. So we now have that title, which is the key. We have the value, which is we have the Toy Story 3, which is the value. So when in Python, you have to be deliberate in what you want. Like when we're defining the function, okay, we're deliberate what we wanted. We say if movie information, we know the first index should be title, so we put title there. So don't go and put anything else and say, okay, it's going to call it for you. Even if you put something else, it will bring out that something else. But you have to be specific with what you're looking for. You have already seen what we want. You have seen that what we are looking for is in a dictionary form, okay, and it's not a test. So you have to be deliberate. And dictionary has to do with it has to do with key and value. This is the key, this is the value. So you have to call it like that to have it exactly the way it is on the website. So we have the title, which is the Toy Story 3, directed by Lee Uncle Rich, screenplay by Michael Andit, story by John Lester Andrews Staton, the Uncle Rich, produced by Dalake, Adafink, and so on and so forth. These are the actors that were in the movie: Tom Hanks, Tim Allen, Joan Cusack, Don Rickles, Wallace Shawn, John Rasenberger, and Stella Harris. So these are the actors, these are the informations of that Toy Story 3 movie. So look at this thing now. You find out that it's not regular, and we want to make it consistent. Like this budget now, this is how much they use for the movie. So it's actually 200 million. So why do we have /SAO inside it? Why do we have this one? Box office. Why do we have this SAO? These are things that are not necessary, and we want to clean up this particular data so that we can have it in a data frame format. So cleaning up the extracted data, you're going to define a function, def get underscore content underscore value row. If row.find LI, please, we want it to return in string form. Okay, because what we are seeing there is string, is not numeric. Okay, so we want it to appear in a string form. So whatever it needs to be converted to string, and it has to appear in a mix. So we are saying, okay, bracket open, square bracket, li.get underscore test bracket open. So this is also getting the test of the information you're extracting from the data, from the website. And that's saying dot replace. Anywhere you see SAO, please replace it with nothing, if possible with space. Okay. So, and because we have lots of it, we have to use replace function twice. And I say, okay, this one here, we don't want to replace it with nothing. We don't want anything to be there, just want to have 200 million. And you have to specify where you want this function to take place in. It's taking place in LI in row.find all lists. Are you understanding me now? Because this thing want to happen, want it to happen, not want it to happen in row.find all LI in this particular function. I don't know if you're understanding me. So at this point, we will now say else return row.find cd dot get test dot replace SAO dot replace this and that. So they're saying if this condition is not met, it should still go ahead and replace. Okay. So you try to say if the condition is not met, still go ahead and replace it. So when you run the function, so you know this function we have run now, we're going to use it later. So we'll now create another dictionary where we will have if index is equals to 0, clean underscore movie underscore information, title. Then you also want to have our value, which is row.find.th.get test. So we want our title, the value of our title to be in a test form. And we also want it to be that let our title, let the information be separate. Let me show you something. Like this production company now. Production companies, it's supposed to be production space companies. They're not supposed to be together. You understand? So this strip function here is to make it for them to be separate. Okay. So we want all our titles to appear in elif index equals to 1. That is, if you get index 1, please continue. Okay, don't stop, because when it gets there, it's likely to stop or maybe kind of bring out the pictures that you don't need it. So we now say content underscore key equals to row.find.th.get test, where you want those particular all those particular the keys want strip to be applied. Like there should be space where it should be necessary. You understand? We don't want where it's being jam packed together. So we now say content underscore value equals to get underscore content underscore value. So we are calling the function here. Then we now say okay, clean movie. Then we are calling this our dictionary and creating. We want our content key to be equivalent to content value. So we want to have a key calling the key and a value. Okay, so that's it. So when we do this, you find out that all those SAO is out. This our production company is separated and is looking within. So at this point now, we're going to put this whole thing in a dictionary, in a pandas form, okay, in a table form, in a structured form, because it's looking unstructured, okay. So when you now say pd.data frame bracket list cleaned underscore movie underscore information dot items bracket close. That's we're trying to call this information here. No, I didn't sell it. So when you run this, so when you run it now, you can see that the movie information is in a data form. It's now in a table form where you have It's not orderly. You have the title, so Toy Story 3, directed by Lee Uncle Rich, screenplay by Michael Andit, story by Person, by Dala K. Anderson. These are the actors in the movie. This is the cinematographer. It's edited by Susu Person, music by Susu Person. So this is the information we extracted from the Toy Story 3, and we have put it in a paper form, in a data frame format. So this is it. So at this point, I don't know if you have any question. Please, can we ask? If you have a question, please ask your question. Maybe your computer and you want to ask a question. And please, I want you to go online and look out for Python libraries you can use to do web scraping and read about web scraping, download some PDFs and get information and download some materials on web scraping and learn web scraping more. Because web scraping is quite vast and there are different documents. You have to learn how to scrape documents, PDF, scrape documents, PDF, scrape different websites. There are some websites that you can't scrape, so you have to ensure that you can scrape some website. Don't just go and keep for. You have to go online, go to Google and search for websites that can be scraped. Some cannot be. So websites are restricted. So that is your work to do that and all. So I don't know if you have any question. Please, can you ask the question? Please, if you can hear me, can you identify that you can hear me? I beg. I don't know if I've been talking to myself. Okay, there's a question here. Someone is asking, Tanya Shekawat is asking, what are different scores in web scraping used for? Example, positive score, negative score. What is that supposed to mean? What do you mean by positive score and negative score? Well, I really do not understand by what you mean by scores and all. Maybe you can rephrase your question so that I can understand. Tanya, please kindly rephrase your question. Because I don't really understand what you mean by score and negative score.
I have a question and it's possible to ask it.
Like the scores used for variable analysis. Okay, at this point now, we are talking about scraping information from websites. Okay, we're not using, you're talking about the accurate scores, the ROMSE scores, root mean scores. No, it doesn't have anything to do with web scraping. Web scraping is different, something entirely. You apply scores when you want to like when you want to web scrape, it has to do with Python libraries, using Python libraries to web scrape. Okay, so I don't understand how positive score and negative score really come to play. And please, in your project, you have to make sure that you are web scraping a website. Please don't go to anywhere, don't go to Kaggle and get a data set. No. Please, we want the data set to be generated from a website. Okay. Generated from a website so that we can be sure that you truly web scraped. So that we can be sure that you truly web scraped a website. We don't want you to go and You know, when you're talking about automation, you're saying I should explain automation. In web scraping, we have robotic process automation. It utilizes bots to automate the process of web data extraction from selected website and store it for you. You know, and this particular thing, if you want to do automation, you have to use some high Python libraries, okay, like Scrapy. I mentioned a Scrapy, SCRAPY. That is what it is used for. That's automation, okay. So right now you don't need that particular library. What you need is beautiful soup to use and scrape, because we're not doing automation. Yes, you can actually use Scrapy to do that, but the thing is, whichever Python library you want to use, you can use beautiful soup, you can use Scrapy, but this particular okay, she's saying that she doesn't know about her question. Just heard my colleague teachers talking about it. Well, this thing you're talking about is for advanced scraping, just like that's what I'm explaining to you. It's an advanced type of scraping. Okay, I don't think that is what they are requesting you to do at this stage. Okay, so it's about automation. Okay, it's about automation. Web using automation it's a process of web data extraction from selected websites and store it for use. Do you understand? So this particular automation is used for selected websites. So it's not all websites. So you have to find out that particular website you are going to use and know which Python library to do it with. But Beautiful Soup does not use automation. This particular library I use today does not use automation. Another Python library. Okay, someone else is asking, and can we web scrape videos with Python libraries? I doubt that is not possible. Though it's possible with some advanced Python libraries though. But I'm sure of pictures, you can web scrape pictures, you can call pictures into the Python Jupyter notebook. But as for videos, I'm not sure. I'm not really seeing that. So when you're trying to scrape pictures, but it will come out as the title of the picture will come out, you know. Then you have to now, there are different other ways. You have to save the picture, then read it from another angle to have your picture displayed in your Jupyter notebook. But you can scrape text. You can scrape text, like all the text here can be scraped and put in a subheading. You can scrape and get this subheading, Toy Story 3. You can even get all the information, all the text under this Toy Story 3. You can scrape text successfully. You can even scrape tables like this other one. These are tables. And like this particular subheading, this plot here, you can scrape it and scrape the word under it. You can scrape it. Then you can also go further to scrape all the information down here. Although I used to be a believer, I do. He's so much older. Aren't you, Gretchen? If you wanted to speak to Mr. Harris in private, didn't you? Yes, I do. I'm going to use that conference room. So is there another question? you have another question, you can kindly ask me. Okay, if you have a question, please kindly ask me. So Tanya, I want to further explain on that automation, right? What automation does too, it helps to automatically save whatever information you have gotten in a database. Okay, once you have scraped an information from a website, you download it to your Jupyter notebook, then you are sure that you have extracted it, you clean it up, then there's this automation process that you can automatically save your information in the database. Some people even go ahead to create the data, like write information about the data when it was when it was downloaded, when it was modified, when it was created, and so all those process these are things you will get to know later. Okay, so right now we are taking it one step at a time. You don't have to rush the information so you don't get confused. So someone is saying, please, I use Collab. Is it the same method with Jupyter Notes, or there are workarounds? Okay, well, Jupyter Notebook is good. Collab is also good too. They all have their disadvantages and all. Like there are some like for Google Collab right now, you cannot use it without data. You must have internet docs, and it has to be very strong. It has to be very, very strong. But in Jupyter Notebook runs offline. You get, you don't even have to have data before you can work with Jupyter Notebook. Then in Google Colab, you can run anything and your kernel will not crash. It will protect. You cannot crash your kernel, you cannot crash the system. But in Jupyter Notebook, there are some things you cannot. People will say you should be careful, don't just browse and put anything on your Jupyter Notebook. It can crash your system depending on the strength of your system. So you have to be careful too. You have to be careful, but it's best to use Google Colab so that you can run anything, you can run any Python library, you can install, you can do whatever, as far as you have data and the internet is very strong. So I don't know if you have another question. Any other question, please? If I've answered your question, Gospel, can you, send me a message that you have understood what I said? Okay. Yes, of course. So he's asking, so if I run this same code on my Colab, there won't be errors. Which code are you talking about? Is it my own particular code? So how are you going to get the Jupyter Notebook? Okay, fine. If you copy whatever I've put here to run it on Google Colab, it will run, definitely. It will run. It will run definitely. There's no difference. They are the same. Just that this one runs online, this one runs offline. Have I answered your question?
Yes.
Huh?
You have. Thank you.
All right. So any other question?
No, from me.
So please then note that if you go to if you go to Google Colab, if you go to Cargo to download any website, you will be discredited. Though. Don't even try that. You have to go to a website and scrape data. Then you analyze it. So either you analyze, you conduct data analysis on it, then do data visualization, storytelling with it, We're not expected to go to even such a query language to download any data. Okay, so you have to make sure that you're obeying the instructions to avoid being discredited. Let's avoid that. So if you have, I'm giving 5 more minutes for any other person that wants to ask questions. Now finally call it a day. All right, in the absence of no question, I've already told you what you're supposed to do on this particular stage. You are supposed to go to a website and scrape data set from it. Okay, analyze it and put it in the data frame. Then continue what you're supposed to do on the data according to the information being made available for you. So please do that and ensure that you don't go to any website and download any data. No, you're supposed to scrape. You're not supposed to download any data. You're supposed to extract data from website, and you have to show all processes of which you use to extract that data. Okay, you have to show all the workings. You have to show the code, how you extracted the data from the website. Just as I did my own. That's how you do the videos. You can even search for other ways to do it. And you have to make your researches and read further. So that's it. So at this point, we're going to call it a day. Do have a beautiful day, and thanks so much for joining. Thank you.
Thank you.